Good afternoon, guys and gals. This is Keith here coming at you again with actually another one of my models. This one, some of you may remember several weeks ago that I posted a kind of a teaser video on the new model that I'm coming out with. I finally got all those models printed and getting ready to do the build now. But before we start that, I wanted to get into some real deep detail about this model. The more you know about it, the easier it's going to be for you to work with it. I should actually say there's three models here. If you worked with twig trees before, you'll know that starting from the bottom up, the bottom has the most twigs on it, and the twigs decrease as you go up. So I had to make multiple models to handle different numbers of twigs. And this is what the model looks like. What makes this model so unique is the fact that it has moving parts on it. I designed it this way so the tree can be folded up for storage. Now I said that there were multiple models on this tree. This one here is a 7-arm model. We also have a 6-arm, and up at the top we'll have a 4-arm. Now, as I said, these models, being models with moving parts, are very difficult to create on the 3D modeling software and have some intricacies that you need to take note of before you start working with them. So let's go right into our 3D modeling software and our slicing software, and I'll get into real detail about this. So this is a model in SketchUp. Most of you already know I only use SketchUp. It's a little more difficult, but it's what I'm used to. I'm going to give you a little overview of the nomenclature of this model. First off, the center hole here is perfectly sized for a 1.5-inch EMT pipe. A lot of you on your trees worry about the wind bending the tree over and all. Well, this is only a 10-foot tall tree, and 10-foot EMT should be plenty strong enough to handle it. You look at these areas right here. This is kind of a cradle for the connecting arm here. It prevents it from moving side to side and pretty much eliminates the possibility of the connecting rod actually breaking off. When I initially designed this part right here, I had designed as a square, and I found out that right across the center here was a weak area. So I went back in and beefed these up a little bit. So they should be plenty strong enough. Working on up the top here, the sleeve here is thick enough to where it's plenty strong. Have this hole here that allows you to mount it to your EMT pipe with self-drilling screws. Now we can go into the X-ray mode here, and I'll give you a little view of the inside of this thing. This is where it gets really interesting. You'll see we have the connecting arm here, and in the center of that connecting arm at this end is a rod. That rod sits inside kind of a cylinder sleeve there. What makes this work is this little dip that I built into it here. The purpose of this is to allow your slicer to print support material or add support material into this area to support this center rod here, and that keeps it from adhering to this outside cylinder. It keeps them separated. Once you really look at it, it's actually a fairly simple design. These holes in the connecting rod are sized for a 1/4 inch fiberglass rod. A lot of you know that I've been using them a lot lately. As for this model, I think they're going to work very well. The bottom layers of the twig tree are going to have probably 2.5 foot long rods, and in some models sag would be an issue on that. And this, on a twig tree, that's not an issue. A twig tree is meant to be random like that. So the most that the fiberglass rod is going to sag is 1/4 to 1/2 inch, and that much sag you won't even notice on a twig tree. So let's go ahead and move into our slicer. Now I'm using Cura here. We'll go ahead and start up at the top for my settings. Layer height at 0.32. It doesn't have to be pretty, so 3.2 is just fine. The first important thing in slicing this is these settings in your shell. I have my walls thickness set at 2 millimeters. This setting here is the most important, the top thickness. That's your area right in here where all your pivot rod, we'll call it, where all this stuff is. That needs to be printed as solid as you can. And I found that a 7 millimeter top thickness does pretty well on it. And I have the bottom thickness at 2 millimeters. And fill's not real important on this. 25%, just fine. I use a grid pattern. Now we get on down to the bottom. This is where the really important stuff comes in. Your support material. It's not too many models that you print as support material is the most important part of the model, but in this case it is. We'll go ahead and take this into the layer view and I'll show you what I'm talking about. First thing to note, put your support everywhere. And you would think that would be a problem with these holes in your support rods here. But the next setting, the overhang angle, I have set high at 80%. That 80% prevents it from adding support into these connecting arm areas. Trust me, you don't want to try to dig support out of those holes. I use a line pattern and density of 25%. That's plenty enough. Here is the first very important setting on this. I'll go ahead and take you down. Get an inside look at this. This is the support that it builds for those pivot rods in there. And you'll see I have a line direction of 40 degrees. The purpose of this is to keep all these at an angle. That's the way that performs the best, I've found. How you position your model on your build plate and your slicer is an important factor in setting this up. Your line direction may be a little bit different than mine, so you just have to play with it. But the issue is you want to get these at an angle. It makes them easier when it comes to breaking these apart. The support Z distance I have set at 0.165. That is your distance from the top of the support material to the bottom of the part of the model that it's supporting. I found that 0.165 in Cura works best for me. Now, one thing you'll note, Yeah, like I say, you may have to play with this some. Different printers and different slicers are going to work differently. On mine, this works well. When I take this off the printer and I pop this arm up, the pivot rod here separates nicely from the support material. So you may have to do a couple of prints to find out what works best for you and your particular slicer and printer. If you look at the bottom here, print time for the 6-arm model here is 14 hours and 28 minutes. Realistically, that's a little over 15 hours. I found that the 7-arm model takes around 16 hours. 6-arm model takes around 15 and some change, and the 4-arm model takes a little over 13 hours. So it's not too bad print time. What makes it bad is the fact that you have to have 19 of these hubs to build a full 10-foot tree, and I'll show you that once we get down to the workshop. Let's take this on down a little more. You'll see the support material for where the connecting rod extends out. That breaks off very easily. And this is a support material for the connecting rod itself. Once you print it, you'll find that it pops off pretty easily. It doesn't really have, as long as it's not hanging out, it doesn't really have to be taken out. I take all mine out just for cosmetic purposes. But it doesn't get in the way if you leave it in there. So that gives you a good idea of the inner workings of this model. But the biggest thing I want everyone to note on this, I share my models with the intention that the user can modify it, adjust it in any way they want to for their use. But on this particular model, I strongly suggest you do not mess with this area in here. If you make changes or adjustments to this area, you could ruin the functionality of this model. It's very precise. To give you an idea of how precise this model is, the last adjustment I made to it before I called it a production model was 5/1000ths of an inch. So this is very precise. Another example I'll give you is when I was first working with this, I wanted to adjust the size of it a little bit. But I ended up adjusting my width more than I did my height. And this area ended up as ovals instead of cylinders. And needless to say, an oval inside an oval does not pivot well. So I got that corrected, but that just gives you an idea of how much a little bit of change to this can ruin its functionality. So hopefully that gives you enough detail on this model. So let's go ahead and move on down to the workshop, and we'll get a look at how this thing is going to come together. So before we get started here in the workshop, I wanted to throw this graphic up for you. This will tell you anything and everything you want to know about this twig tree. Each level has a block on it that shows the level number, the number of twigs on it, how long the fiberglass rod is on that level, and the number of pixels on that level. So the first thing we have to do for this build, obviously, is to collect everything we need for it. And to give you a little list, starting out, obviously, is your hubs. For this build, we'll need 19 hubs. You'll need 6 7-arm hubs, 9 6-arm hubs, and 4 4-arm hubs. You also need your EMT, one 10-foot section of 1.5-inch EMT, Won't need to be cut because we'll use the full 10 feet of it. You'll also need your fiberglass rods. As you can see here, I already have mine pre-cut. The chart that I displayed earlier will show you the exact length you need. Basically, the first row is 38 inches long, and each subsequent row after that, as you go up, reduces by 1.5 inches per row. You'll also need some 3/4 inch number 8 self-drilling screws. That's to mount your hubs on the EMT pole. And this one is one that'll probably raise a few eyebrows. On this build, we're actually going to glue the fiberglass rods into the hubs. Now, a lot of you older people probably remember back in the day when we made these little model car kits. The glue that we used to glue the plastic pieces together was Testors. Testors is still on the market, still available, and it works great for plastic. Now we are gluing fiberglass into plastic, so this is kind of a test for me. I'm not sure how it'll work binding the fiberglass to the plastic, but I don't think it'll be a problem since these fiberglass rods fit so snugly into these holes. But we'll see how that goes. Extra thing you may want to get, these are 18-inch Velcro tie-down straps. This model is being built to where it can be folded up. You fold each individual level up, wrap it with a Velcro strap, and it works great for storage. I do this on my 15-foot twig trees and it works great. Tools you'll need a drill for running in your self-drilling screws, Phillips screwdriver for tightening them down by hand, tape measure so you can position your hubs exactly on the EMT, and that's pretty much it. This is actually a very simple build, very quick and very easy. The hardest part about this whole thing is prepping everything, mainly printing your hubs. 19 hubs, if you print one hub a day, you're talking 19 days just to print these. The cutting your rods, it's not that big of a deal. It takes about an hour to cut all 112 of them. Okay, so let's go ahead and get started putting this thing together. First thing you want to do is make the marks, measurements for positioning the hubs on the EMT. My design, there's 6 inches between each level of twigs. Obviously, you can redesign this however you want to. You can add more distance between the levels and reduce the number of hubs you need. But I found that 6 inches gives you the good density that you need for a good looking tree. The top hub will go flush with the top of the EMT. So basically it's just a matter of going down, making a mark every 6 inches. I'm fortunate enough to have a 8-foot by 8-foot table that I built for my workshop here. So it makes things a lot easier, gives me plenty of area to work with. However, once we get these hubs on, we're going to have to move outside to stand this thing up to put the hubs on. Okay, I have all my marks on here. Now, one thing I want to go back and show you is something that I do on mine. You don't necessarily have to do this unless you want to. Everybody knows that a 3D printed model is not perfect. You're going to have little imperfections in it. Now inside these holes, if you have imperfections, it can make it tight whenever you're putting your rods in there. Make it a little harder. These holes are size for 1/4 inch rods. What I do is I take a 1/4 inch drill bit and do a little light drilling inside of each hole. I stress the word light because you don't want to damage these things. Just run the drill bit in. Give it a little light rubbing on each hole. This will ensure that your rods go in smoothly. I've already done that on all of mine, so you don't have to watch me doing that. The next thing we're going to do, go ahead and slide all these hubs on here. As I said, the first 6 levels are for the 7 arm hubs. The next 9 are for the 6 arm, and the last 4 top ones are for 4 arm. The center hole on this is sized perfectly for this 1.5 EMT. I was talking about imperfections in your print. This one here, I'm going to have to do some smoothing out on the inside of the hub because it doesn't want to slide on too well. And I think this one as well. That's no big deal. Take a piece of light sandpaper and smooth it out some, and it should slide on easily. I'll go ahead and do that off camera, and we'll be right back. Okay, we have all our hubs slid onto our EMT. Next step, just to position the hubs and use your self-drilling screws to lock them down. First hub will just be flush with the top of the EMT. When you're running these screws in, do not run them in all the way, or you're going to take a chance of cracking your plastic. That's the reason you need your Phillips screwdriver. That way you can finish them off by hand. Get them good and snug. They don't have to be too tight, they're just holding the hub in place. Once you get the first one in, the rest of them is just a matter of aligning the top of it with your lines that are 6 inches apart. Now, one thing you should note here, to get the full look of a twig tree, you don't want to line these twigs up. You want to alternate them, stagger them. You have 2 twigs here. Take this twig, put it right in the middle, and it'll give you a good stagger between the twigs. And it doesn't have to be perfect. A twig tree is a random all your twigs and all your lights are in a random pattern on a twig tree. To tell you a little bit about a twig tree, is kind of an abstract version of a real tree. Now, most of us know that our mega trees, everything's lined up perfectly, vertically and horizontally, to give you good, clean effects. Twig tree is not like that. Twig tree, you want totally random. And I'll show you more about that whenever I show you how to put the lights on this thing. But that goes the same for the twigs as well. Alright, it's going to take me a few minutes to get all these hubs positioned and screwed down, so I'll do that off camera. I'm sure you don't want to sit there and watch me. And we'll be right back. Okay, we got all the hubs in place now, perfectly spaced in between, staggered, so you get that good full look of your tree. Next step, obviously, is to glue the twigs in. Like I said, this is pretty much a test for me. I think it will work out well. We have our tester's glue. I would suggest putting a bead right around the edge on the top. That way, as you slide your twig in, it gives a good coating. Now obviously I can't do 112 twigs here on my workbench. So what I'm going to do is I'm going to take this thing outside. I've made a little stand for it. I'm going to stand it up and put all the twigs in with it standing up, and then I'll come back and show you what it looks like once we get them all in. And that, ladies and gentlemen, is how you build a 10-foot twig tree quick and easily. Total time for putting this thing together, including cutting the twigs, is 3 to 4 hours. Like I said, obviously the printing of the hubs is the most time-consuming thing on this project. Once you get through with that, the rest of it is very easy. So we'll take a camera in and give you a close-up look at this. Now, as I said, I'm not sure how the tester's glue is going to work on this. I may add a little bit more glue on top of a stronger type to ensure better support. But I think it's going to do all right. Now, I'm not going to put all the lights on this and do a preview of it like I normally do, because I want to get this video finished and get it out there so anyone that wants to can start working on this. Have plenty of time for it. I did want to give you a couple of pointers on putting lights on and folding this thing up. As far as putting lights on, as I told you earlier, twig trees are random creatures. You do not want your lights perfectly lined up and all pointing the same way. You want that random effect. The easiest way to do that is to put your string on, give it a couple of wraparounds, and then zip tie it down. And you can see in this way, you have lights pointing in all different directions. You have to look at your lights as kind of a abstract representation of leaves. Leaves don't all point in the same way, so you want your lights pointing in different ways. Now, as far as the orientation of your lights, you want each level to go on the same way, be it counterclockwise or clockwise. And you also want your first twig of each level to be lined up all the way up. Now these are staggered, so you just have to go with the closest one to keep that line all the way up. Now, I mentioned the Velcro straps to you earlier. Purpose of this tree having moving parts on the hub is so it can be folded up for storage. I'll give you a little example of how that works. Now, obviously this will be a little more difficult when you have the lights on, but it's not that bad. These are 18-inch Velcro straps. When you get the lights on, this thing will be a little fatter, so I would suggest 24 inches or greater for your Velcro straps. That gives you an idea of what it looks like when it's folded up. It is 10 foot tall, which will make it more difficult to store. However, you can cut this thing in half and build you a connector in the center and make two pieces out of it if you want. That's totally up to you. I have plenty of storage myself, so the 10 foot doesn't bother me. So that completes our build of the 10 foot midi twig tree. I'll get out there and get these models in the file section of 3D Printing for Christmas Light Enthusiasts and post this video, and I hope you guys get some use out of this. I think this is going to be one of my more popular models. Well, thanks for watching, guys.